Most business breaches aren't one big exploit, they're a chain of small failures stacked together. A weak input field becomes a database access becomes stolen credentials, weak password storage becomes cracked passwords. And one risky feature, like file upload, can turn into full compromise. Today, I am walking through a vulnerable Flask app created by our own colleague Tom Thomas for Wolfcore. So thank you very much, Tom. I really appreciate what you've done here. And this box will be downloadable from our website so people can practice ethical hacking safely and more importantly learn how to stop this happening in real companies. Tom's got a few more things to fix on here, but he's gave me a quick little access to it, and I'm going to have a go with it and talk to you about this. So this isn't just a random capture the flag. This is designed to look like real business functionality. Search, user data, authentication, and admin style features. We're going to run a realistic attack chain, and I'll translate each step into a real-world business impact. Speaking of real-world business impacts, let's get into that already and put the relation in. This exact chain applies to basically every industry that runs a portal or a dashboard. Healthcare, patient portals, billing systems, SaaS, admin dashboard, and customer portals. E-commerce, product search plus accounts, finance reporting dashboards and client portals. Education-wise, student systems and staff portals. If it has a login page and a database behind it, this is actually relevant. So while I'm doing that, before I start talking about the attack chain, I'm going to start the Nmap scan already in the background for us, and I'll talk about what I'm going to demonstrate here. Number one, I'm going to demonstrate SQL injection through a search parameter. Enumerate the database and find user tables, dump password hashes, then crack a weak password hash via offline, then log in with the valid credentials, and then we get to test out how dangerous the file upload feature is. In that section, what I'll do is I already have a custom remote command shell to execute. We'll upload that and see how we can access it and see if we can get a listener with that as well. And at the end, how we secure each layer properly. And that's what I'll be talking about. So already we've got the Nmap scan, and what we see in here is port 5000 is open and it's titled an online shop, and it's running on Wexzook HTTPD 3.0.1, and it's a Python based application. So I know in the background that this machine is actually running on a Windows 11, so it'll be quite interesting to see when we try the remote command execution via this vulnerable web application written in Python, whether we'll actually be able to get access to the Windows 11 machine, which is fairly new. So first things first, let's get access to the actual web application and check that out. So that is on port 10.211.55.9 and it's running on 5000. Right, so we've got a web page online shop created by Tom, and we're seeing laptops, smartphones, headphones, and their pricing. There is a login page and a home page. Now the area we're going to concentrate is going to be the parameter. So SQL injection happens when an app uses user input inside a database query without proper parameterization. So for example, I'm going to look for an Xbox. And if I type in Xbox, it gives me search equals Xbox. No product found for this. However, as we can see, there is a parameterization there for SQL. Instead of this app asking a database a safe question, the attacker manipulates the query logic. In the real world, SQLI is how attackers steal customer records, staff accounts, internal data tables, and anything the app database user can access. Now I'm going to use exactly this with an automated tool to confirm the injection and enumerate what tables exist. The tool is in the story. The story is that the app is letting user input influence database behavior. So go back into the terminal. I'm going to use SQL. So I'll do SQL, and I already got this set up. So right here, I'm going to type in dash dash tables. And it starts retrieving some information here for us. So it's brought up 4 tables. What we're looking for is the proof that the backend query is injectable and that the database structure is discoverable from the outside. Once the attacker maps the database, the next target is identity data, because credentials turn a bug into an account takeover, and that's where the damage ramps up. Now we dump the user table, and this is the moment it becomes a real breach scenario, because next I'm going to try go for password hashes, and then after that we can crack it. Now the one main thing here that's popped out at me is first one, flags, products, SQLite sequences, but users. Now for me, users is always going to be the first one that I ever look at. So let's try have a look at the records now. So we'll do SQL, exactly almost the same search pattern here. Then we go -t, users, -- dump. And let's see what it'll dump for us from that. So it's dumped us a raw seller with the password of this and username admin seller. So we've got the username, and by the looks of it, what we have is MD5. In this lab, passwords are stored using a weak fast hash. Fast hashes like MD5 are a gift to attackers because cracking becomes realistic, millions of guesses per second, and business suffer here because of password reuse. Once cracked passwords can unlock emails, VPN, admin panels, and more. So next here, I'm going to save the hash in a file so I can crack it locally. So I'm going to do file, new terminal, and I'm going to do vi hash 1.txt, and gonna save that here, and then go back to here, copy this, move over to here, and I'm gonna paste it, save it, and once that's saved, my next command is going to be John -- format equals raw -md5 -- word list equals stolen passwords and hash 1.txt. And there we go. So we've got secure pass 1, 2, 3. Now we get to go back on the actual page here. Admin seller with the password. Not going to save it. Seller dashboard. There we go. So add new product here, and as well as from this we get to access view images as well and edit them. Perfect. Which is what we wanted. So it gives us already some kind of user in this section using that real password. This is why password storage matters. Once hashes leak, cracking is offline and your app protection don't help, basically. Now we move from exploiting the vulnerability to using legitimate access, which we just did there. This is the pivot point in real incidents. Attackers log in like a normal user, then abuse permissions. Now that I'm logged in with the cracked credentials, let's do the remote command shell and see if we can elevate this. So I want to add a product. I'm going to name mine Xbox. This is a hack and gonna give it a good price of $1 million. Browse, and inside this folder here, I've already got a custom one, and this is the reason why I'm leaving this out. I don't want people to see this, because when it comes to being on our website, I want people to use their own shells so they can get access. So adding product, and I'm going to move this to the side, and then I'm going to grab this one and move that to the side, and I'm going to open up a port nc-lvnp 4444, get that listener ready, and I'm going to scroll down and see if my Xbox appears anywhere here, which, there we go. So Xbox, this is a hack, $1 million, image shell.py, so that means that they're missed out on the bit where they need to really review what files they should allow on and what files they shouldn't allow, what files they should allow on and what files they shouldn't allow on. And business upload invoices, prescriptions, profile photos, documents. If uploads aren't controlled, uploads become a major attack surface here. And this is me showing you a weaponized payload step by step. And it just proves that the file doesn't validate, and the file gets stored somewhere and doesn't get handled safely, because this is a real security lesson. I'm checking 3 things. Does it block unexpected file types? Does it store upload safely, ideally outside the web root? Does it rename files and prevent risky handling? Yeah, so let's actually give an access to this file now. View image, disconnect, which is good sign that it even tried connecting. So if I run nclvnp again, and there we go, we actually have connection. So if I do dir, we've got cmd, and there we go, and that's exactly where it's being stored. So that is the full chain: SQL injection, database discovery, user tables dump, hash cracking, valid login, abuse of normal feature. And that's the business lesson: attackers chain weaknesses. To fix an SQL injection properly, parameterized queries everywhere, no strings, concatenation, safe ORM usage, input validation as a helper, not the main defense, least privileged database accounts, login and alerting on abnormal query patterns and error spikes. Next, security-wise, the password storage. For passwords, remove MD5 entirely. It's very obvious, that one. It can be cracked very, very easily, especially with stolen password lists. Use Argon 2 or Bicrypt with strong cost. Unique salts per users, optional pepper. Multi-factor authenticate for admin accounts. That's a quite simple one to do. Rate limiting and lockouts on login, because once hashes leak, weak hashing turns into an offline cracking. So then we come to the secure file upload. For uploads, strict allow list of file types. That's quite important to do. Validate MIME type and file signature, not just extensions. Store outside of the web root. Random file names, never trust user paths. Virus scan and size limits. Disable execution permissions in upload directories as well. Next up, we'll talk about detection and monitoring, and that is pretty much like the final one I'm going to talk about, and then we'll do a different episode next. Monitoring catches chain early, right? Alert on SQLI patterns and DB error spikes. Really important, especially if you're going to do SIEM or kind of SOC. That's very important to understand, and how the defense of that is set up. Alert on mass data access or exports. Alert on new admin sessions and privilege changes. Alert on unusual upload activities. It is worth always monitoring. Monitoring is going to be a best friend in regards areas like this, especially in the defense. You find out exactly what needs to be fixed, fix it, and then keep a monitor on it. If your business runs on web apps, and this is the mindset, attackers chain small weakness into big outcomes. So that's the full breach chain. One input flow, weak hashing, and one risky feature, and suddenly your business app is owned. If you want more real world labs like this, hit subscribe, because the next videos will be deeper, faster, and based on actual attacks paths we see in companies. Comment your tech stack and let me know. If it's Flask, .NET, WordPress, Node, and I'll pick one up and build the next lab around it. I'll be doing some more Hack the Boxes at some point. I know that Tom is working on another box for us soon, which will be something to do with a bank, so that'll be quite exciting. He's only hinted me that. So subscribe so you don't miss out in the next lab. Thank you guys, and I really appreciate all the support that I'm getting at Wolfcore as well. Thank you.